My name is Richard Riels. I'm the Executive Director to the Sea Mammal Education Learning Technology Society, SMELTS, and I'm going to give a presentation on the fishing and testing of innovative ropeless lift bag fishing gear to reduce entanglements in marine life. The big picture: we've made significant progress over the last year. We've developed new software for the SMELTS ropeless lobster rafts and the Teledyne Universal Topside Deck Box, the UTS. We capture more raft data, more subsea location information, and unique identification files that we can apply to the fisherman's gear so we can find this gear and understand where it's going to be subsea. We developed the Sea Cloud, a new website to populate this information. We have 4 different modems that we've been playing with and understanding this communication technology. We have the new ability to upload the UTS data to the Sea Cloud with access to the fishers and the regulatory agency. And we are going to continue this work. Technical accomplishments. Under the Massachusetts Letter of Authorization, we're currently fishing lobster rafts in the Gulf of Maine with our partner fisherman, Rob Martin, and we are harvesting ropeless caught lobsters. We built an offshore lobster raft for Woods Hole Oceanographic Institution for deep water lobster fishery, and we're beginning our trials. We tested lobster rafts in high current deep water in Maine, Frenchman Bay, Mount Desert Rock area, lifting 3-pot trawls and very challenging bottoms, deep water, high current area. Building a Sea Cloud, a cloud-based website to provide real-time data to fishers and monitoring agencies of virtually marked ropeless rafts. We're testing in Cape Cod Bay with the Teledyne Bentos UTS marking system and exporting data to the Sea Cloud. So we're finding the gear subsea. Integrating Blue Ocean Gear smart buoys on subsea lobster raft and compliant hybrid trawl line. So we're marking the gear on the compliant line and we're sinking it subsea, and we're marking the gear before the lobster raft submerges and when it returns, and this is a location verification. The system is a very good platform for ocean data collection, temperature, forces, battery, and ultimately the location. Designing and preparing to install the ropeless acoustic equipment and the fishing vessel Resolve to reduce operational time and ease of use. Integrate the acoustic transducer into the hull, installing the deck equipment in the wheelhouse and in the helm, making a much more seamless use of the acoustic equipment on a fishing boat. We've had some great recent testing in some real challenging waters in Maine. We've been setting the gear around Frenchman Bay and Mount Desert Rock. We've been relocating the gear with our GPS location technology, and we've been lifting 3-pot trawls in these challenging bottoms. This is a video of us hauling. We are triggering the gear and hauling the hybrid trawl from the ropeless side, and we're catching ropeless lobster here. The lift bag has been triggered and it's made it to the surface. We have our GPS and our McDermott signaling lights. The bag is incredibly visible, has soulless tapes, it's very reflective, and stands proud in the water. The fishermen are getting the gear back onto the boat. They deflate the bag. Rob is packing the gangin. He'll tuck that into the bag. The gangin is all that's really needed on the lobster raft to get that gear back on the boat.
Hi, this is Claudia Mueller-Thompson. I'm going to talk to you a little bit about the SMELTS Sea Cloud. The code for this application is actually open source and it can be viewed on GitHub. The website was developed using Ruby on Rails and it's hosted on Heroku, which is a platform as a service that enables developers to build, run, and operate applications entirely on the cloud. The database we're using is PostgreSQL, and it's hosted on Amazon Web Services. We also use AWS Simple Storage Service, otherwise known as S3, for device event file storage. So basically, this is a website with a very powerful database backend. The way it works is the first step is the fisherman creates an account on smelts.org. When they deploy the SMELTS ropeless rafts, the modem on the raft sends the data to the Teledyne Universal Topside Deck Box on board, where the data is collected, and then it's made available by the UTS to a USB. And the fisher has to take the USB and upload the data to the cloud. Once it's visible to the fisher and the monitoring agencies on C-Cloud, there are many powerful things they're going to be able to do with it, and I'll talk about that in a moment. That's today. Tomorrow, the data is going to be made available by the UTS directly to the cloud. So no middle person has to walk around with a USB. The data that's available on Smelt C-Cloud to agency users will be things like the fisherman name and permit ID, the date and time of set or retrieval of their rafts, the location of the rafts plotted on a nautical chart, and they'll be able to enter a specified area and see all the rafts deployed in that area. For fisher users, they'll have access to their raft data, of course, with date and time of set or retrieval of their rafts, the raft locations, again plotted on a nautical chart, and the location of rafts from other fishers. So they won't see whose rafts are there, but they'll see that they are there so they don't place their rafts on top of them. Richard, back to you.
Our next steps for 2021, we have a very busy year. We're going to continue to support our partner fishers with gear support and training. We're going to continue developing and testing our subsea marking capabilities, expanding on our location, our file gathering, the development of our C-Cloud, and populating this information. Build more gear for the gear cache and our partner fishers. And we're going to test the new deep water design we've been working on to 350 meters or greater. Last thoughts. The importance of the hybrid trawl. This is a very important concept we've been working with, and I came up with about 4 years ago. A ropeless unit on one end and a compliant vertical line and buoy on the other. This allows a key strategy for adoption and the success of ropeless technologies. It gives us time. It gives the fishers time to understand the ropeless system. It provides the fishers with a backup if the ropeless system fails. It gives a chance for us gear vendors to get that gear back and understand what failed and not let that happen again. It gives the regulatory agencies time to understand the change needed for marking the gear and how it will be done virtually. It gives some strategies for this and some time to understand what needs to be done and how it needs to be populated. This concept removes 50% of the vertical lines and 50% of the threat to marine life. I want to thank an amazing group of people and funding supporters and all of you that are taking time out of your day to pay attention to this great problem. And we have to give a solution to the marine life that's swimming out there, living in the ocean, and the men and women that work in that environment. I want to thank Julia Rugo, Acoustics Application Engineer. I want to thank Rob Pinelli, Senior Software Engineer for Teledyne, Ryan Grimard, SVP Engineering for EverQuote, Rob Sterner, Senior Application Engineer for GitHub, Claudia Mueller Thompson, Director of Product Management, Aquia, the Pew Charitable Trust, the NOAA Bycatch Reduction Engineering Program, the National Fish and Wildlife Foundation, Blue Planet Strategies, Blue Ocean Gear, and the Island Foundation. And again, thank all of you.